All right, 16.2b. We're doing some more solving, but look at these equations. Are they missing something that you're familiar with right now?
Yeah.
What are they missing? They don't have logs in them, do they? But where is the x located in each one of these problems? In the exponent, which means we are probably going to need to use logs to solve it in many of these cases. Now, we don't always have to, but a lot of times we do. So, before, when we had a problem like this, how would we solve this? We would get these things called matching bases. I would say 4 to the x equals 4 to the second, right? And as soon as I have these matching bases, that tells me that x equals 2. Yes? Or you could have said 2 squared to the x equals 2 to the fourth and set 2x equal to 4. Either way, you end up with x equals 2, right? Doesn't matter whether you got the matching bases to be a 4 or a 2, as long as you got matching bases. Now, we can do that for some problems, such as this one. Because if I look at 9 and I look at 27, I can't write both of those as a power of 9, but I can write them both as a power of what? 3. So, what can I write 9 as? By the way, I'm going to keep the exponent of 2x right there. And what else? What can I call the 9? 3 squared equals something to the x minus 1. And what can I replace 27 with? 3 cubed. Yeah? So do my bases match now? Big numbers are both 3, right? So guess what? 2 times 2x equals what? 3 times x minus 1. Or in other words, 4x equals 3x minus 3. You following me? Mm-hmm. Move your 3x and x equals negative 3. Could I check my answer? Yeah, I always could. I could plug that back in and see, does this side actually equal that side? But in this case, I don't have to because I didn't have any logs to worry about taking a negative number of, right? Can this problem be done the same way? Can 81 and 1/3 both be written as a power with the same base? What base would that be? So I'm going to take a minute. Before I fill in that base, I'm going to say 81 to the 3 minus x, I just took out the 81, equals something to the 5x minus 6, because those exponents have to stay. What number am I going to use as my base? 3. I know that 1/3 is 3 to the negative 1 power. 81 is what? 3 to the 4th power, because we know 3 to the 1st is 3, 3 to the 2nd, 3 to the 3rd, and then if I multiply that by another 3, I get 3 to the 4th is 81. So far, so good? Do I have bases matching? So what can I do? Look at my exponents. 4 times 3 minus x equals negative 1 times 5x minus 6. So let's see, I have 12 minus 4x equals negative 5x plus 6. And we can solve for there. I'm going to move the 5x. And if it's okay with you, I'm going to subtract 12 in the same step because I'm running out of room. So I have x equals what? Negative 6. Do I need to check it? I don't have to check it because I didn't use any logs. But if I'd like to know that my answer was right, then by all means go check it. Okay. So? All right. How about this guy? Can I use that same method? Can I get 4 and 15 both to be written with the same base? Nope. So what would I have to do? Guess and check, maybe? Well, I can use a different method. When I can't get the same bases, I can use a different method, which is going to log form. So if I were to write this in log form, what would my base be? Log base of equals, how do I solve log base 4 of 15? How do I solve log base 4 of 15? Change of base formula. What does the change of base formula say? It says that I can solve this if I put what into my calculator? Log 15 divided by log 4. So let's see what I get. Log 15, close my parentheses, divided by log 4. And what do I get? 1.953. Do I need to check my answer? I don't have to check it because I didn't have to take the log of a negative number anywhere. But I should be able to see, I know that 4 to the first power is 4, and 4 to the second is 16. Well, 15 is pretty close to 16, isn't it? So x should be pretty close to 2. Is that pretty close to 2? I have a reasonable answer. I would at least go there to verify that you're in the right ballpark. Make sense? Okay, so let's look at this guy. Am I going to use, by the way, she has it listed as 2 methods here. Method 1 is what we did up here with the matching the bases. Method 2 is what I just did here when we can't match the bases. What should I do for this guy? I can't even think about bases right now because I don't have my exponent by itself, or the power, the term with the exponent. So what do you think I should do first? Let's subtract the 4. So I have 2 times 7 to the 3x equals what? 20. Is my exponent by itself yet? Nope, so I can divide by 2. So 7 to the 3x equals 10. Can I use method 1 of getting the same bases? Oops, sorry, I didn't mean to put that off the screen. Can I get the same bases? Nope. So what method do I need to use? The second one, going to log form. So what's my base if I go to log form? Log base 7 of 10 equals 3x. So far, so good? How do I figure out what log base 7 of 10 is? Change of base. Log 10 divided by log 7. Yes, I know that equals 3x, and I'll deal with that in a minute. Let's see. Log 10 divided by log 7 gives me 1.183. Let's stick with 3 digits past the decimal. Now, notice I have not cleared my calculator because I have not gotten x by itself, have I? Now, how do I get x by itself? Divide by 3. So don't clear your calculator. Just hit divided by 3, and I get 0.394, and that's my answer for x. Can I check it? Absolutely, I always can. I don't have to check it, though, because the only logs I didn't have to worry about taking a negative number. Okay? All right, looking at a few problems down here. Am I going to use the matching bases or the change to log form here? change to log form. I can't get 5 and 24 to be the same base. So this would be log base what? 5 of equals 3x. What do I do from here? Change of base, right? Log 24 divided by log 5. So let's go ahead and see what log 24 divided by log 5 is. Log 24 divided by log 5, 1.9746. What is that going to round off to? 975. Divide it by 3, and x equals, so I didn't clear anything, just hit divided by 3. Why is it important that I didn't clear anything? Because I don't want to have to type in a rounded off decimal into my calculator. I want to use the whole decimal as it was. Now I can round off for my final answer. 6582 would be 658, and that's my answer right there. So? Okay. What about the next one? Which method would I use here? I can get the matching bases, can't I? So let's see. I have something to the 3x equals something to the 2x minus 7. Do I need to change this 5 at all? Nope. So I'm just going to leave it as 5. What about 25? Has to be 5 squared. So 3x equals 2 times 2x minus 7, right? 3x equals what? 4x minus 14. I'm going to go ahead and subtract 4x. Yes, that will get me a negative x, but that's okay. Negative x equals negative 14. I can either multiply both sides by negative 1 or divide them both by negative 1. Either way, I get x equals positive 14. Okay. All right, what about this guy? Well, let's get the exponent by itself first before we decide. Let's move that 1. 5 to the 3x equals 16. Can I write 5 and 16 with common bases? No. So we got to go to log form. Log base what? Base 5 of 16 equals 3x. How do I solve log base 5 of 16? Change of base. Log 16 divided by log 5 equals 3x. So let's see what log 16 divided by log 5 is. It's 1.723. Divide both sides by 3, and x equals 0.5742 would be 574. So? What about this last guy? Almost the same problem. Almost. What should I do first before I decide? Add 1. 5 to the 3x equals 25. Should I get the same bases or should I go to log form? Same bases. By the way, it doesn't matter which way you choose. If you have something like this, you can go to log form if you want to, and you'll end up in the same place. Okay, so you said same bases, so I have 5 to the 3x equals what? 5 to the second. So what do we have? 3x equals 2. Divide by 3, and x equals 2/3. My preference, whenever possible, is always just leave it in fraction form because there is no way to write that as a decimal without rounding off. So 2/3 is actually more accurate because you don't have to round anything off. Does that make sense? I think that's the end. The back is blank. So your homework tonight, worksheet 16.2b, is solving exponential equations. I think it's all exponentials, whereas last night's was all log equations. Some of these you will be able to solve using the matching basis form. Some of them you will have to use the go to log form. Okay? All right.